Toyota is on the cutting edge of innovation, particularly within the arena of electric vehicles. Their novel solid-state batteries serve as a testament to their commitment to exploring uncharted territories and producing technological marvels. Nevertheless, the innovation does not exist solely within the electric vehicle landscape. The auto giant is amongst a handful of companies that still hold steadfast to the potential of hydrogen engines as a feasible alternative. And recently, they have raised the bar yet again, with the development of a potentially industry-altering invention, an ammonia engine. In order to fully grasp the implications of this technological advancement, it is essential to first understand the fundamental components and working mechanisms of an ammonia engine. Put simply, an ammonia engine represents a category of internal combustion engines that use ammonia as fuel. Ammonia, a chemical compound made up of one nitrogen atom and 3 hydrogen atoms, is a carbon-free fuel. Hence, its combustion doesn't produce any CO2, unlike oil or gas, thus marking a significant stride in the reduction of pollution. The methods of putting an ammonia engine to work are manifold. For instance, the compound can be broken down into hydrogen and nitrogen, where the former is utilized to generate electricity within a fuel cell. This technique has been employed by a startup named Automotive, enabling them to create what they claim to be the world's first ammonia-powered zero-emissions tractor. Another approach entails the blending of ammonia with another fuel, diesel, gas, or hydrogen, which is then set alight. This facilitates easier ignition and sustains combustion, a technique exemplified by MANES in their 2-stroke green ammonia engine for maritime applications. The third method requires the use of ammonia as a singular fuel, necessitating advanced technologies like spark ignition, compression ignition, or homogeneous charge compression ignition. Ammonia engines hold several advantages over their counterparts. The compound's high energy density, affordability, efficient and easy transportation, quick refueling time, and widespread availability make it a highly attractive option. In addition, it can be produced from hydrogen and nitrogen, elements abundantly present in the atmosphere. Acknowledging the enormous potential that ammonia holds, Toyota has decided to team up with Chinese state-owned manufacturer GAC. Together, they have recently unveiled a prototype engine capable of combusting liquid ammonia. Ammonia has already been recognized as a clean fuel alternative for a range of vehicles such as ships, trucks, trains, and even airliners. The joint venture between Toyota and GAC, however, posits that this compound could also be a viable candidate for fueling passenger cars in the future. To test this hypothesis, they have successfully developed a prototype engine that operates on liquid ammonia. The outcomes have been remarkable, particularly in terms of emission reduction, with estimates suggesting an astounding 90% decrease in comparison to conventional fuels. This breakthrough was proudly announced at a recent Tech Day presentation by GAC. The event marked the unveiling of a cutting-edge 2.0-liter engine, ingeniously engineered to burn liquid ammonia in a safe and efficient manner. Chi Hong Chong, an engineer at the GAC R&D Center in Guangzhou, stated that they have successfully resolved the challenge of rapid ammonia combustion, thus enabling its use within the passenger car industry. According to Bloomberg reports, this revolutionary engine achieves a peak power output of 120 kilowatts, making it a formidable contender when compared to other fuel types. In addition to this impressive power output, it also drastically reduces carbon emissions, thus emerging as a greener alternative to traditional fuel sources. It is noteworthy that while GAC and Toyota may be eager to brand their engine as the world's first, it is not the sole venture into this field. A decade earlier, the Korean Institute for Energy Research undertook trailblazing work, resulting in the creation of a car named AMVET, which ran on a blend of 70% ammonia and 30% gasoline. This unique combination led to a significant 70% reduction in carbon emissions. The AMVET team was passionate about investigating the feasibility of a fully ammonia-fueled engine, and their work serves as a powerful precursor to Toyota and GAC's project. The GAC engine's design, which utilizes liquid ammonia as fuel, does indicate the production of carbon dioxide, suggesting the incorporation of an additional fuel source. This setup could provide a pragmatic solution considering the characteristics of ammonia, such as its slow flame propagation speed, which often presents challenges for engines functioning at high RPMs or low engine loads. By amalgamating ammonia with another fuel, the GAC engine may have effectively addressed these limitations, ensuring smoother performance across diverse driving conditions. The journey of integrating ammonia engines within the automotive industry is not devoid of obstacles. One of the most significant challenges is the current lack of an established infrastructure for refueling ammonia-powered vehicles. Unlike conventional fuels, ammonia is not ubiquitously available at present. This necessitates the development of a comprehensive and secure refueling system. Despite this potential setback, the current scenario presents an opportunity for industry innovation, fostering the creation of a safe and efficient infrastructure that can cater to the distinct needs of ammonia fuel. The development of engines that utilize liquid ammonia as an alternative fuel represents an exhilarating breakthrough for the automotive industry. It introduces novel possibilities and opens the door to a future that is more sustainable. Liquid ammonia could serve as a viable fuel alternative, offering reduced carbon emissions without compromising performance. As the world continues to prioritize environmental conservation and sustainability, the adoption of ammonia-powered engines could play a pivotal role in achieving these objectives. Nevertheless, it is crucial to acknowledge the potential downsides and challenges that ammonia engines might pose. A significant drawback lies in ammonia's propensity to produce high levels of nitrogen oxide, NOx, emissions. These emissions contribute to air pollution and have harmful effects on human health and the environment. Thus, the reduction and control of NOx emissions will be a critical aspect of making ammonia engines more environmentally friendly. Another considerable challenge stems from ammonia's relatively slow flame propagation speed compared to conventional fuels. This characteristic can complicate the attainment of optimal combustion efficiency, particularly at high engine speeds, RPMs, or during low engine loads. The slow flame propagation speed can lead to incomplete combustion and power output reduction. Overcoming these performance limitations would require substantial engine design and optimization efforts. Researchers and engineers would need to delve into innovative techniques to enhance combustion efficiency, such as optimizing fuel injecting systems, modifying combustion chamber designs, or implementing advanced ignition systems. Additionally, the existing production process for ammonia primarily depends on the Haber-Bosch process, which is associated with high emissions. The Haber-Bosch process requires substantial energy inputs, and its environmental impact must be taken into account when evaluating the overall sustainability of ammonia as a fuel source. It will be worthwhile to explore alternative methods of ammonia production that are more energy efficient and have lower emissions to further improve the environmental profile of ammonia engines. Another challenge lies in the cost and availability of ammonia. At present, the production and distribution of ammonia are not as widespread or cost-effective as conventional fuels. The Haber-Bosch process, often relied upon for ammonia production, requires substantial energy inputs and infrastructure investments, contributing to the overall cost of ammonia fuel. Moreover, a reliable supply chain for ammonia distribution is currently limited, further hindering its accessibility as a fuel option for the general public. In terms of safety, handling ammonia requires careful consideration as it is a toxic and corrosive substance. For instance, in the event of a leak, it can pose hazards to human health and the environment. Therefore, the safe storage, transport, and handling of ammonia as a vehicle fuel will be a key concern that must be addressed. This would likely necessitate the development of new safety standards and protocols, as well as the adoption of specialized materials and technologies that can withstand ammonia's corrosive properties. Furthermore, the acceptability of ammonia-powered vehicles by the public and industry stakeholders is another aspect that needs to be tackled. The unfamiliarity with ammonia as a vehicle fuel, coupled with concerns about its safety and performance characteristics, could potentially hinder its widespread adoption. Therefore, efforts will need to be made to raise awareness about the benefits of ammonia engines, dispel misconceptions, and build confidence in this new technology. While the development of ammonia engines marks a promising step towards cleaner and more sustainable transportation, there are still numerous hurdles that need to be overcome. However, with continued innovation and commitment from industry leaders like Toyota and GAC, the vision of a carbon-neutral future powered by alternative fuels like ammonia could well become a reality.